Well, hello everyone. I'm back for another update here. Today is March 11th, 2024, and I'm going to go more into this video about how the MJO is being manipulated to create warm weather for the populated areas of the planet by manipulating the path of the jet stream to take a certain course that will favor warm weather, especially for the eastern U.S. and for other populated areas of the planet as well, that they're targeting to buy into this man-made climate change. So right now, I'm looking at the current weather. Reason why I'm looking at Australia and Indonesia is because that's where the warmer phases of the MJO originate. We see all this green north of Australia. This all represents convection occurring, but notice how you go in this direction, you don't see as much. So what that's indicating is the MJO is dominant in phase 4, which is here, 5, which is here, and 6, which is here. You got a lot of convection in these zones. It causes the jet stream to take a path that favors warm weather for the eastern U.S., and it has been like this pretty much most of the winter. As you can see, and the MJO still remains in this position here. In order to get colder weather for the U.S., this area needs to be relatively free of convection, and other areas need to have convection along the equator. The MJO is based on the Intertropical Convergence Zone, which is an area of naturally occurring convection, usually near the equator, and it tends to come in pulses, and naturally, on its own, it would never stay in one phase all winter. It usually shifts. You may have it here for a couple weeks, and then and you may even have a winter where it dominates for a good part of the winter, the certain MJO, but it never stays in the same position. Now, how are they doing this? How are they manipulating the MJO? They have developed, there's so many satellites up there, and they have developed technology where I feel they can beam infrared energy in certain areas to enhance the convection of a region, or enhance a tropical storm to become a hurricane perhaps, or even enhance severe weather to occur over a given locale. They can enhance the convection to a level that would be far beyond what would have occurred naturally. And given that this area has an ample supply of warm water in this region, they can very easily enhance the convection to where it's feeding off this energy in this region by firing infrared energy from satellites into these cloud tops in this region. They can cause the convection to be a lot more intense than it normally would be otherwise. And of course, they succeed in doing this and keeping this convection cluster going here. They can cause the eastern U.S. to have a record warm winter because it will influence the jet stream to take a path that will bring air from the equator northward into the Gulf of Mexico and ultimately into the eastern U.S., which is what has been happening pretty much all winter, almost unabated, which is why we've had a record warm winter. It has nothing to do with actual global warming. They are just positioning the jet stream by manipulating this MJO to stay in this warmer phase. They will continue to do so probably until about May 1st. And then you will see the weather take a turn toward cooler conditions. But of course, by then it's going to be pretty much too late to get any significant snow in the U.S. As far as the eastern U.S., the places. Now we're going to go east. As you can see, notice the relative lack of convection. We need the convection to be here to have a cold winter for the eastern U.S. We need the bulk of the convection to be in this region. So the pattern is opposite. And the interesting thing is, this is the second winter in a row. They claim there was an El Nino this year. With an El Nino, we would have warm water in this region, which should, theoretically, naturally encourage convection to occur here, which would put the MJO here, which should normally give the eastern U.S. a colder winter. So either one of two things have happened here. Either there's not much of an El Nino going on, or hasn't been. I mean, you see there is a little bit of convection here, but not much. As we go east from here to Africa, we could see there's a little bit of convection, but not enough to put the MJO into a colder phase. As well as the Indian Ocean western, you need convection here clustered to get a colder weather pattern, but again, there's not much. Look at the comparison. We go back to this region, look at all that convection occurring. And maybe some people might say, well, this could be random. Global warming could be causing all of the convection to stay there. Probably not. Again, naturally, the pattern never stays like this all winter on its own. Usually the MJO will shift to different regions. And yeah, you may get a pattern that's a little more dominant than the others, but normally you don't have the MJO 2 straight years staying in one spot all winter for 2 consecutive winters like this. It doesn't normally happen. There is definitely some tinkering going on. And I think of a magnifying glass. When I was a kid, I used to start fires with a magnifying glass using pure sunlight. And that's infrared energy from the sun. So I suspect that they are taking this energy and from satellites, using them like you would use a magnifying glass to concentrate the energy into certain particular areas where they want to concentrate it, the heat energy to get the convection going. And you beam perhaps some intense infrared energy from the sun at certain areas of the clouds to put some heat there to put convection fired up. Then once the convection gets going, it feeds off the heat of the ocean surface, and that keeps it going. That is how I feel they're doing it. Now we're going to go north and talk about how Siberian air is being dumped into the Pacific here, and I'm going to try to zoom in on this to try to get a better view. This is Siberia up in this direction. Siberia is up in this region. You can see all of this pale color in here. This is all cold air pouring into the North Pacific. behind this low pressure system, just centered along the date line in the Pacific, you can see all this speckled white coming down around this side. This is all Siberian air flowing over the North Pacific. I'm going to try to... You can see this huge bomb cyclone over the North Pacific, pulling colder air from Siberia down over the North Pacific. All this Siberian air is being modified, swept down by this low pressure system here into the Pacific, being modified, so nobody's really going to feel the full effect. However, what it's going to do, if this repeatedly keeps happening, the North Pacific is going to get cooled down. You got a little bit of a ridge down here on the east side of this front. Hawaii is down here. They're getting a little bit of a rain event from a subtropical low pressure system right there, is giving them a little bit of rain, but it's a cutoff low. It's not associated with the main jet. And then we could see here, this is another push of cold air coming down from the Bering Sea, just coming down to just off the west coast of the U.S. You can see, follow the tongue right here. This is another push of cold air over the North Pacific. Of course, it's getting modified. By the time it reaches the west coast, it's going to be considerably modified. But the Sierras and Cascades are going to get a good dumping of snow out of this system right here. But then you go eastward to the U.S. and look at how benign the weather is. Nothing really going on, because you got that. We do have a little bit of a cool down here, but you got a ridge coming up over here, a trough here. You do have a low pressure here that departed to New England. They gave a lot of snow to New England, but it's moving away now. And this ridge here is going to come back east and bring the warmth back, at least to the eastern U.S. But on the other hand, in contrast, eastern Canada is going to get nailed with some more snow. They got a blizzard there last week. Newfoundland received, I think they said, 75 centimeters of snow in one storm a few days ago. And that's this storm that's now south of Greenland. That dumped 75 centimeters of snow on Newfoundland. And that is moving away, but this weather system that brought snow to New England is going to bring more snow to Newfoundland in the coming days. Moves up that way. And we could see, go out to the North Atlantic. There's another tongue of cold air pushing down to the east of this front. A narrow tongue pushing way south. But then we go to Europe. We got a little bit of a ridge poking up here, just over Portugal. And then we got another system over Eastern Europe. So we can see right now the weather in the hemisphere overall is pretty active, but over the U.S. it's benign compared to what the rest of the hemisphere is experiencing. So now I'm going to go to the National Weather Service page. You can see the movement of the systems. And let's go to the satellite images. First, I'm gonna go to the North Atlantic and look at the infrared. Where you could see things a little more clearly as to where the cold air is going. This is northeastern United States. This is New York City, New Jersey, Pennsylvania, and we can see, notice this low pressure that brought the snow to New England is now over Nova Scotia, and Newfoundland is getting clocked with more heavy snow from this system. You can see all the cold air, mainly to the east, looping around. I mean, the northeast is getting some of that cold air. Notice the shadow of as the cold air hits the water. Notice how far offshore it is. So the worst of the cold is further east, and New England and northeastern U.S. are getting clipped by it, but the worst of it is here. This is where the bulk of the cold anomalies are, is in this area where you see me pointing. We got a little bit of a ridge poking up here. There's a lot of rainfall in this region. You got Greenland up here. But notice, look, another tongue of very chilly air going way south over the North Atlantic where nobody lives. Except for the Azores, perhaps getting a little bit of a chill out of that. But then we go east, there's a ridge poking up over Spain and Portugal. So we're going to go to the Canadian and notice over the U.S. in general how benign the weather is over the eastern two-thirds of the U.S. compared to other places. Yeah, you do have a system coming over the Rockies, but it's getting washed out. It's not holding together. It's heading up toward Canada. You got this system crashing into the west coast. You can see the cold air. That cold push of air from the Bering Sea coming down toward the Pacific Northwest, but notice the trajectory. It's kind of getting washed out. It's almost like there's a barrier here stopping it because of that ridge. So this cold air, chilly air, is not going to make it very far east. It's going to be deflected back up into Canada, mainly. But the Sierras and down here are going to get a dumping of snow. The Cascades are getting a dumping of snow in Washington, Oregon, and also up in British Columbia. But most of this weather is going to end up staying north. This here is headed toward California. It's going to bring some rain to the coastal areas. Now let's go to the North Pacific. And you can see Alaska right here. Notice all this blue. This is extremely cold air up over northern Alaska and over eastern Siberia. And up over the northern part of Yukon also. These temperatures are 40 below and lower in this region, showing up as a dark blue. Notice this low over the Gulf of Alaska. Notice how it's not moving much. So all this cold air, you can see the source of it getting pulled down by this low, but it's coming out over the Pacific. It's getting modified. By the time it reaches the west coast, it's not going to be very cold. Notice how this low is just sitting here. It's not really moving, so this is going to continue happening. You got another push of cold air. This is Siberian air coming down over the North Pacific as well. Over the Aleutians, you got a low right there, sitting there as well. So we could see almost the entire North Pacific, with the exception of this region, is covered by Arctic air, modified Arctic air, but it's still below average temperatures that they're not talking about. And this is going to cool the waters of the Pacific. It's going to alter the patterns of the Pacific Northwest, cooler, wetter overall. And now we're going to go to see what the MJO looks like. Unfortunately, I can't get to the phase 4 and 5 zones on this. You could see kind of a little bit of it on this. You can see right here. Notice how dark the colors are. Notice how you see explosions going on in the cloud tops here and here. This is not naturally occurring. There is energy being fed into these convective cells here, and they're in the phase 6 MJO zone, which warms up the eastern US. There's some more up in the top corner here as well. Further east, there is some naturally occurring convection. Notice the difference in the colors. They're not as dark red, and they're more diffuse. It's not like it's a pinprick area where you see, like right there, especially right here, these two areas, you can see the explosion effect going on. I'm going to go to the full disk, because most of the convection is now in phase 4 and 5. It's hard to see on the National Weather Service images. They don't go far enough west to look at that zone very well, but might show up better on the full disk image. Now you look over in the far left. This is the image of the entire Pacific, and this will put things a little bit into perspective as to why the weather is so warm, been so warm lately overall. We got New Zealand down in this region. See if I can move it down a bit. New Zealand is down here. The phase 6 zone of the MJO goes all through this region. Notice all the dark reds going on there that are perpetually seem to be that sitting there. They're firing energy from satellites at this area to enhance convection, this whole region, to make it a lot more intense than it normally should be. When it's this intense, it influences the jet stream to take a certain position and stay in that position, stuck. Thus, you get in the eastern U.S. A winter with no snow, because the air almost all winter, the jet stream is carrying air from the equator. Let's move this image up. And you can see that equatorial flow. Follow this is that low pressure that I showed you earlier over Hawaii, but follow. You can follow the flow. It goes from Hawaii out of this low, moisture streaming to the southern tip of Baja California, across northern Mexico, into the Gulf of Mexico, and on to the southeastern U.S. Now, right now, it's just going across northern Florida and heading out into the Atlantic. A week ago or a few days ago, it was coming straight up into the Mississippi Valley. That's what that MJO does. It creates that flow that I just showed you and keeps it going all winter. That flow coming from the equator or near the equator, coming across Mexico into the northern Gulf and into the southeastern U.S., transporting warm air from those regions northward to places that don't normally receive that kind of air mass all winter. In a normal winter, the jet stream comes up and then comes down like that. At least in 20th century, that's what the flow has been. That's why this winter's been so warm. All it takes is just a slight shift northward in the jet stream, and you're on the south side all the time getting warm air. Cold air stays up in Canada. Has that been true for the entire hemisphere? No. As I showed you earlier, you look out over the North Pacific, notice all this cold air. To the north of Hawaii, pouring down over the North Pacific from the Arctic regions, and then it gets to the west coast and it just stops dead because you got that ridge over here that's deflecting it all up into Canada. So I hope you found this discussion interesting. There is definitely manipulation going on. Are they going to keep getting away with it? No, because eventually they're going to lose the heat energy from the waters of the ocean. They're taking a lot of heat out of the Earth's budget to do this. Eventually, the bank account on heat's going to run out, and as I touched on, the global temperatures are going to go in the other direction. Solar cycle, let's go to solar cycle 25 before I end this. So currently, let's see, sunspot number is down to 77. These regions all here are rotating off the disk, so the number is likely to go down even more in the coming days. Let's see. We do have a couple regions possibly, but they don't look like they're anything huge. So we're down well under 100 in sunspots right now. The cosmic ray count is up to just minus 3.4 now. Let's go to the, and let's see, it's 5960. You can see in the chart below the trend has been, in cosmic ray counts, has been climbing in the last few days, last week. And the overall picture, it's flirting with -5, but it's up to -3 now. That would put it up about here if it continues. And again, to put things in perspective, in previous cycles, 24, the reason why 24 didn't go as low, I think, is because here the northern hemisphere fired up, and then here the southern, so they were both 2 years apart. Now we got both hemispheres at the same time. So what's going to happen is this dip isn't going to last as long. It's going to start going back up very soon. You can see in previous cycles how much longer the cosmic rays remained lower for longer periods, below -5 and below, for several years at a time in these previous cycles. And cosmic ray count goes up, it leads to a cooler climate due to increased cloud cover. Cosmic ray count goes down, it leads to warmer conditions. The sun does rule our climate, and always will. Man will never trump the sun on climate. And that is going to be it. I'll be back soon.